Hi guys, today we are going to be solving another problem. It's a medium problem from LeetCode. It is called product of an array except self. In this, what you will be given is an array like 1, 2, 3, 4. You will be given an array of numbers. What you have to do for the output is return an array of numbers such that you get the product of all the elements except the indexes element. Like for 1, you wouldn't be including 1, but you would be including the product of all the others. That's 6 and 24. For 2, it's 12. For 3 it's this 8, and then for this it's 6. So this is what we have to do. Okay, and also in the question it is given that we can't use the division operator, or we can't use the division operator. If we can use this, what we could have done is first of all calculate the entire product of the array, and then for each element in the array, what we would be doing to get the product of the array except that element is dividing the total by the array element. So this would be giving us the product of the array except that element. But that's why they did not give this in the question, and they asked us to not use this. Okay, so we have to find a different kind of a solution. So first of all, brute force. Now seeing this, because we can't use the division sign, division operator, what we have to do is be a bit creative. We could only use multiplication. So how could we do this in a brute force? Whenever we say brute force, think of for loops. First thing that has to come is for loops. Okay, so in this, for every element, what we have to do is find the product of the array. So that is what we will be doing. So for every element from I equals 0 to n minus 1, what are we doing? Finding the product of the array. And how would we be doing this? We will be having another loop. But what we have to do is check the condition where we don't want the element itself, the array element itself, right, at that index. So for that, we could do is I equals not equals j. Okay, when this is not equals to j, results time equals array of j. Now we could have a variable called results, not here, here, and then we could just append that to an answer variable or answers int, something like that. We could just push this answer into that, and then finally return that. So as you can see, we have two nested for loops in this. Our time complexity for this is O of n square. And coming to the space complexity, it's O of 1, because we are not using any extra space except for the result variable, and considering the answer that we are returning to be not using any memory. Okay, so now coming to the optimal solution. So they asked us in the question to write an algorithm that runs in O of n times. Now how can we do this? Do that? So in the previous thing, we saw that we had multiple loops that are going on. For every element, we are going from the start till the end. Could we do this in a better way? So what we could do is first calculate the prefix sum, sorry, prefix product, then the postfix product, and then multiply the postfix with the prefix. We will be getting the answer. I will be showing as to how this would work. So let me take the array as example. First of all, this is the array. Okay, and our output must be something like 24, 12, 8, and a 6. Okay, so first of all, what we are doing is creating a prefix array. So in this array, what we would be doing is putting in the values of the prefix product values for the element. So for one, before elements, there are no before elements. So we would be assuming this as a default case, and we would be putting in 1. For 2, the previous element is 1. So we would be adding that in the array. For 3, the previous elements are 2 and 1. The product of these is 2. And for 4, the previous elements are 1, 2, 3. And the product of this is 6. Okay. Now, this was the first loop, or first iteration in forward direction. Now, similarly, what we will be doing is having a postfix array that's like this. And what we will be doing is second iteration from back. Okay, so in this previous one we went from here to here, now we will be coming from here to here. So if that's clear, let's see as to what we'll be doing. ah. So for 4, the previous elements are nothing, right? Sorry, not the previous, the after elements are nothing, so this would be 1. Okay, for 3, the element that is after 3 is 4, and the 4. For 2, the elements that are after it are 3 and 4, and the product of this is 12. And then for 1, the elements that are after it are 3, 2 and 4, and the product is 24. Okay, now we have our prefix and we have our postfix. What we would be doing is our answer would be equal to, we would be multiplying this and just adding those to our answer. So it would be 1 into 24, 1 into 12, 2 into 4, and 6 into 1. This would be giving us our answer 24, 12, 8, 6. Okay, you could say that these two match. So now coming to the time and space complexity, because we are just having 2 iterations on the array, our total time complexity would be O of 2n. But since we ignore the constants, this would be simply O of n. Now space complexity. Now for this, the way that you see is we are having 1 array, 2 array, and 3 arrays that we are creating in the memory. And if you ignore the answer array to be taking the memory, then it would be 2 arrays. That's prefix and postfix array. Okay, so our space complexity would be O of 2n, that would be O of n. But what we could also do is, instead of having 2 prefix and postfix arrays like this, what we could do is first initialize the answer array to contain all these elements. Okay, and then in the first loop from I equals 0 to I equals n minus 1, what we'll be doing is answer equals pre, and pre times equals nums of I. Okay, so here prefix equals 1. Now this is the for the first one. Now for the second iteration, what we could do is I equals n minus 1 to I equals 0, answer it times equals post times equals nums of I, post equals 1. So here what we are doing is we are changing the values in place. Okay, so if we don't consider the answer variable as taking any space, the space complexity would also be O of 1. So this is the product of array except self. So now let us just look into the coding part of this. Let's just get into the code. As I said, we would be having a array called answers, that's an integer, and this would be initialized to what the size of the numbers and with zeros. Okay, so what we could also do is, now what we will be doing now is going through the let me just take this out. We will be having a for loop from I equals 0 equals 0 to I less than nums dot size I plus plus. Why don't I just take this off and put it in a variable so that it's not calculated again and again. So this will be n less than n. So what we will be doing is answer equals pre, and then pre times equals nums of I. Now we did not declare the pre here. Okay, so you could see that we declared pre equals 1 because 1 is a identity multiplier. 1 has identity property, that is, when any number is multiplied with 1, it just brings that number. So that is why we have this pre equals 1. Okay, so this was the first loop that we go from the start till the end and calculate the prefix product. Now we will be having another loop that goes from n to 0, that is in reverse order. Okay, I minus 1. In this we would be calculating the postfix product and then multiplying that to the prefix product stored in the answer array. So for this we would also be needing a variable called post. This is also initialized to 1. So post, oh sorry, answer time equals post and post type equals nums of I, and then finally we simply return the answer variable. So let's run this and see. I seem to have made a mistake. uh, int int hmm, hmm, answer of I 5. So as you can see, it successfully cleared these test cases. Let's just submit to see on the entire test case. You could see that this is the most optimal solution for this problem. Thank you for watching the video.